So basically, we split our 30 minutes, 1 hour into 3 parts because we have a project done together recently. So at the end of my presentation, we are going to present that project for 20 minutes. So my lecture is titled Augmented Craftsmanship, but I'm going to start by introducing my practice first. I made a small short video with a show reel of my earlier sketchy works. My main interest is how to use the computational tools or the latest technologies in a way to help the designers to design more interesting spatial, more interesting structures and spatials, and also conceptually really changes the way we design and create spaces. So especially I have been very interested in generative design using basically the simulations or code-based generative systems to control the generation of interesting geometries that is very intricate and that is not easy to be modeled or probably mainly like impossible to be manually modeled or human created by human hand or human head. So very interested in using the algorithmic processes in the design processes, and then having really interested in how to execute these in a various different materials. And there are also a part of my work is about teaching, and I do like kind of connect my practices and research together and trying to bridge the practice not to be merely a commercial practice, but that can be very much integrated and bridged through the design research as well. So the keyword of the office is architecture, design, and research. And there will be, there is a reason why the lecture is called Augmented Craftsmanship. Basically, I explained already that the main idea is to use the computational design and then the look into the different paradigms and the shift of the technologies and bridging the practice and research. Obviously, we are also collaborating also with Jakub and Igor and with other friends to really trying to get more commercial projects that we can really have build projects as much as possible. We are really trying. For those projects, this is actually in construction now. It's an interior project done by Jakub and Igor and myself. For this kind of project, we also really try hard to kind of push certain conceptual kind of geometries into architectural design languages, but more easily to integrate certain generative tools in a more actual ways in a smaller products or installation scales, which we and then more importantly, the research is really important. How we are also pushing the things that are maybe doesn't have too much commercial value or financial value to really research things through academic platforms. So a part of my work is teaching in Bartlett, and for previous 4 years I was also involved in the same lab, material research lab with Igor and Material Architecture Lab with Daniel Wittrick and Stefan Bassin and Igor, which actually has a lot of influence on the things that I'm going to talk about, this augmentation idea. I'm going to talk two things about this, which is going to be generative design and design fabrication. So basically, use of the code and use of the computational tools really enabled designers to create any kind of crazy geometries and drawings really, really easily nowadays. But the fabrication and the studies of how to execute those complex forms has been very much focused on automation and robotic fabrication, which normally needs very high-tech knowledge and really smart people to calibrate and knowing all this robotic, which is really, really interesting. However, with my huge respect with all these projects from Gio and Manu and Igor, most of these projects are kind of lack of the use of materiality of the actual materials that is used. And there is very much lack of being able to kind of discuss about this delicacy and complexities that can normally come from a human craftsmanship, such as these examples. So to provoke that idea, I wanted to show this project as an example from the same lab, from Material Architecture Lab, which we were calling it RC6. So this project looks very, very kind of Gothic-y and how do I say, like very delicate. And then the left one from Benjamin Dillenberger has also kind of really similar kind of architectural qualities, complexities. However, the one that we produced is actually made by hand. And this is actually done through the development of interesting ways of synthetic material, use of material. In this case, is using the sleeve and casting it with a flexible foam balloon as mold. And the design is actually helped by a generative tool that controlled by the use of agents. And it's not hand modeled, or it was not very easy to model by hand. And then these are actually translated through the looking at the screen, and then translating that into architectural scale or in one-to-one scale through and crafted by hand. And this is a same project it's a different project, but in the same kind of method that is produced in one-to-one. And this is we always test in a larger population to test that in architectural scale in digital reality. However, it was always very difficult for us to translate the digital models more precisely to actual architectural scale, because we were not using robots or 3D printer. We were actually eyeballing from seeing the rotated 3D models in the screen. And actually, the way of the reality that the augmented reality, the HoloLens, became commercialized 3 years ago, actually would have been a very good opportunity for us to really be able to connect these two together. So, so the idea is to provoke the way of using, thinking about labor in digital or computational paradigm or digital fabrication era, to really think about labor to be a different thing. So what we are in this way, we can also really think about what human can do during design and construction processes, because in digital design we mostly lack of the discussion of human intuition and the human abilities and sensibilities to be able to choose or make decisions. But for example, this is a chair design proposals by my students, like this year. I just had to choose this one because couldn't find more other ones. But I think these are done by one person. But actually you can tell, I don't know if you agree with me, but I think this one winning. This one is winning. I think this really the design is really coming to personal and natural talent, and it's really, really difficult thing to teach somebody to become a good designer or having a good design sensibility. And all those things, it really comes to human intuition, a human ability that is very difficult to be taught to teach a computer to do, or to teach a robot to do. So I think in this way of making and designing can really open up the ideas and opportunities for a human ability to really play a greater role in design and production. So I want to just show using this agenda, what we have been developing in RC9 over these 2 years. There are two main different categories in our project, and I will show, first one is about human data integration. The first project is basically, we developed a synthetic panel that can be molded by hand, and then what we developed is very similar to the previous application, but we developed it in augmented reality. And the main idea for this project is to be able to communicate with computer. For example, in this case, the human makes decisions to make changes in the direction of the panel, and then the computer should recalculate and give the best kind of new suggestions. So that if you keep on communicating in this way with computer, human and computer plays a similar role, and then there is a communication together. And then next project is also dealing with very similar kind of idea, but in this case it's working with three-dimensional components, so it's a bit more complicated than the earlier one that I was showing. So this one, you can also see that it's also assembled through augmented reality. Yeah, and in this case, because of their joints are being able to removed because it's interlocking. So they are suggesting a interlocking, reassembling system. So in this case, computer can recognize the new component that is added, and then if human makes changes, keep on suggesting new suggestion. So this one, you can see that whenever it's clicked, the computer resuggests. Yeah, so these two projects were from last year, and unfortunately they were actually fake because they didn't really manage to recognize this actual components. So this year we have a very similar project, but working with a clay component that So basically, this year similar project, but really working with how to recognize through different methods. So in this video clip, you'll see that this is using the Aruko code. If you can recognize the code, so you can actually draw in space, for example. But the main idea is not just drawing in digital world. So this one is a demo reference, and they are using now a motion tracking system that you have to have a very clean room with a lot of cameras in, and you can very easily recognize a point Yeah, and then also the idea is to develop certain machine learning codes that you can actually regenerate, keep on regenerating the new suggestions. So this year is kind of on top of last year. They are really actually developing those techniques in a more clear, real manner. And then there is another kind of category of the projects are more into the materiality. So as the materiality and the crafting technique becomes more complicated, it's a bit more difficult to deal with more complex computational technique. So the later projects I'm going to show three. You will see that the material technique is a bit more complex and the geometry is a bit more complex, but the computational logic is really simple. It's really looking into computer-generated, intricate and complex models and creating them with a very crafted manner. In this case, is using fluid three-dimensional vector fields to generate this pyramid kind of grid system, and then it's used by it's made by stretched plastic. So this was done produced for BPro show last year. Yeah, you can already tell that it's kind of quite complex, but it was very, very straightforward in order to make it. This is what we are developing this year, because last year we did a lot of plastic, that kind of projects, but this year we wanted to really do with like more serious architectural materials. So one project is dealing with really blacksmith kind of twisting of steel bar kind of technique. So this is how when the steel bar is heated up and then twisted, they can create really strong joineries. And this is what they are now developing. They are using this bent bar and the twisted bar as joint, and then bent tubes as separated pieces. And then this chair was supposed to be done for this exhibition, but they didn't manage it. But they are developing this machine to really try to precisely bend the joints. Yes, and we are looking forward to create larger pieces, and they will have to develop this until September, so I'm looking forward to that. This is another project which will be very close connected to our Tallinn project, so I'm not going to talk too much about it, but the main purpose for this main key point of this project is the study of the molding system, because traditional wood steam bending is done with a very traditional and prefabricated mold. And we are kind of really interested in creating a three-dimensional mold that can accommodate different shapes in three-dimensionally. So they are developing actually from a very mold-based mold to clamp the steam bent wood pieces. They are now created this grid of scaffold kind of adjustable molds that can accommodate three-dimensional curves. And the idea is to accumulatively build up on top of this mold. So they designed this small chair that they can actually connect pieces in this manner. And then they are also very much interested in using only wood to connect the entire pieces. So this is their mold, and this is how they are actually bending the pieces through augmented reality, which is pretty precise. Yeah, and then this is the piece, and this is what they are trying to make, and this is what they have right now. And they are trying to create a bigger pieces and joining the woods with this manner. Yeah, and they are looking forward to this kind of scale. Yeah, so coming back to this project, which is not academic project at all, this is Tallinn Architecture Biennale proposal that we entered this with Fologram Guilin and Jan and Cameron Newhan and Igor Pantich. We all entered this together, yeah, so the credit goes to everybody. Initially, the brief asked us to use timber in Estonia in a very interesting way. So we thought the only way that timber is really interesting, or we don't know, is to steam bend. So that's why we just like naturally decided to work with steam bending. And we actually asked our workshop guys who are the expert of steam bending, and then they asked us to make this kind of mold because that's the only thing they know how to steam bend. So for steam bending, traditionally, you have to have the exact designed geometry in order to bend around it. And it was extremely difficult to bend around it, and also because it was very thick, but that was the way. And then we found this artist, Matthias Plesnik, who is actually by far the most interesting steam bend project that we could really find through internet, because he...
Let me add something.
Yeah.
So just to add, basically the reason why we went with kind of three-dimensional steam bending is because the kind of holographic fabrication was an integral part of the project and the proposal, right? So if we would go only with kind of 2D jigs and 2D molds, we wouldn't actually need any use of hologram during the fabrication process itself. So kind of that's why we went into these a bit more challenging forms, and and kind of that's how this actually, even though Soomeen said this is not an academic project, but it's actually turning out to be quite a research project, kind of a very straightforward build. Mouse.
Mike. Yeah. So this artist also had a very interesting conceptual model, bending the steam bend around a classic chair. And we thought this idea is really interesting, and then let's also kind of try to interweave or accumulatively weave through a mold that we can actually dismantle afterwards. So this was our earlier idea, to actually have a three-dimensional, really complex mold, but we can take it out afterwards. And then the initial idea was to create these chunks, and then parts and chunks, and then assemble them together. And this was the first initial test that we did with like really thin veneer, which obviously works very well. And then also we tested with a slightly thicker wood, which at that time we had to use a certain adjustable jig. It was also very difficult to control, but this was also a kind of a test we did at the first stage to really test if this idea works. And then we actually won the competition, and then we had to then now really figure out how to make it. And our colleague Guil, he got this invited workshop in Temple University, and then he decided to test this idea with that opportunity. So he made a small example prototypes of it. It's a different design than our proposal to really test the idea. And then this is how we decided to lay them out with a two-dimensional kind of laid out wooden boards that has specific angle that can be calculated through a parametric model. And then it was kind of works quite well to bend each pieces through this method.
So, but the problem actually occurred in when they tried to join multiple pieces, because they very quickly realized it's very naive thinking that you can assemble this whole thing out of kind of very short elements, meter and a half, because the problem occurs at the ends, right? So if your whole structure is curving, the end remains flat because of the way how it's placed in the jig and how it dries. So shall we continue? And then that was kind of, and that resulted in about, I think, a meter difference between the digital model and the physical model, which kind of on a chunk like this, which was, let's say, 1/5 of the pavilion, is actually huge, right? So that was the moment when we kind of realized that one of the earlier diagrams that you saw when we split it in chunks and then we kind of nicely connected on side, blah, 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 everything is amazing. It was kind of naive, right? Because actually you would accumulate error in each of the chunks that you try to connect, right? So, and then we were also quite lucky to have a chance to do another prototype last week in Aarhus. In the meantime, we kind of revised the whole process where basically we would work with as long strips as possible, and we would always aim to stabilize both ends of the strips in the ground, because that's basically the only point where you can really control where your strip is placed, and then try to match it with a hologram in 3D. Another thing that also really improved the process in the meantime is actually using the kind of steam bending inside bags, but also not removing the piece once it's steamed, but bending it while it's still steaming, right? And then also leaving it to steam for another, let's say, half an hour after it's bent, right? It really kind of helps to keep it in place. And then also kind of a bit revision on the brackets, like you saw in the temple prototype, a bunch of tiny brackets which connect only two pieces, and then we realized basically it would take us forever to build them. So now we are kind of going with an idea of continuous bracket, which would connect 5 to 6 strips, and it would really kind of improve the efficiency, and also the brackets themselves are folded following a holographic template. And then this prototype has, I don't know, like 10% density, but it's basically one, let's say, 20% chunk of the whole thing. And yeah, I mean, I don't know. We just came from Denmark now, so it's kind of quite a happy moment.
this prototype gave us kind of approval that the larger pieces might work quite nicely.
So Soomeen wanted to put this on as well, but now making me talk about it. So if any of the students are really interested in the process and are free and want to join us in Tallinn for some time during the summer for some steamy bendy, feel free to contact.
If you're interested in, but we don't have money. Yeah, so this one is a workshop that we are trying to run to actually help us to fundraise. So if you are actually interested, you can actually scan this QR code to see if you are interested in a 3-day workshop that we are going to actually show and share all of our design processes from concept to the design development.
Yeah, but the workshop is in London, right? Just keep that in mind.
Yeah, thank you very much.
Okay, thanks.